In the first 8 modules of this course, we discussed how wood is made into pulp. Once we have the pulp, what are we going to do with it? If you work in a mill that sells the dried bales of pulp, well, then the pulp is your final product. But pulp is virtually always converted to something else. Maybe it's for the absorbent layer in diapers, or for viscose that is made into rayon. But most likely, the pulp will be made into paper. And that's what happens in the paper mill. Let's start out by making a distinction between integrated and non-integrated mills. An integrated paper mill has a pulp mill that provides pulp to the paper machines. Normally, the pulp is stored in high-density towers at 10% or greater consistency before it's diluted down to 3 to 4% consistency for use in the paper mill. A non-integrated paper mill has no associated pulp mill, so it must rely on purchased pulp, either new virgin pulp in bales or perhaps recycled paper, also in bales. The first job of a non-integrated mill is to repulp the bales in the pulper, which is sometimes called the slusher. A pulper is similar to a kitchen blender since it has a rotor in the bottom or side. Dry pulp bales and water are added, and the bales are agitated until the individual fibers are released. We call this a pulp slurry. Normally, the slurry consistency is around 3 to 5%. That means there are 95 to 97 parts of water and 3 to 5 parts fiber. This may seem like it would be pretty thin, but cellulose fibers can really suck up a lot of water, and the consistency must be around 3 to 5% for the slurry to be thin enough to pump. Once we have a slurry of fibers, we can prepare the fibers for use on the paper machine. And this part of the operation is called, you guessed it, stock preparation, or stock prep for short. The first part of stock prep is called the thick stock system because the consistency of the stock slurry is in that 3 to 5% range. In the second part of stock prep, the consistency is reduced to 1% or less in order to prepare the slurry for the paper machine forming section. Why so dilute? Because cellulose fibers tend to clump together to form bundles called flocks. So we form paper on the paper machine at very low consistency to prevent a lot of flock formation and what the paper makers call pore formation. But let's go back to the thick stock system first and talk about what happens there. If you first look at this part of stock prep, you think, hey, there isn't much going on here, just a few tanks, or what paper makers call chests, and some pumps. But it's more complex than that. Most grades of paper are made of a blend of fibers. If you remember back to the first module of this course, softwood fibers are much wider and longer than hardwood fibers. Softwood fibers are good for strength, but they tend to make a rougher, coarser type of paper. That's where hardwood fibers come in. Hardwood fibers produce paper that's smoother and more uniform, which means it prints better. So if you make something like copy paper, you use both softwood fibers for good strength and hardwood fibers for smoothness and printability. So you need to blend different fibers, but you can only do that if you know very accurately how thick, that is, what the consistency of each fiber slurry is. So measuring and controlling consistency is one of the first functions of the thick stock system. Blending components also means you need to know how fast you're pouring the components together, or what the flow rate is. So measuring and controlling flow is a second major function for accurate blending. Another important function of the thick stock system is refining. Fibers look like hollow straws, and in the paper-making process we want them to flatten out like ribbons and bond strongly together. In order to do that, the fibers must take on water or hydrate, much like pasta softens when it's cooked. Refining is a mechanical way to rough up the fibers so that water can get inside the fiber walls and swell the fibers. Then in the pressing and drying operation, the fibers collapse and bond together. Here's what a refiner looks like inside. It has a center rotating plate with raised bars on both sides and a stationary plate on either side of the center rotor. The fibers are pumped into the middle of the refiner and must make their way out between the rotating and stationary plates, which are set very close together. As the fibers pass between the opposing bars, they're mechanically abraded. Softwood and hardwood fibers react differently to the forces in refining, so usually the different types of fiber are refined separately before being combined in the blend chest. From the blend chest, the final furnish, that is, the blended components of the paper we're going to produce, is pumped to the machine chest. The machine chest is a very important transition point for the furnish because it's the last point in the thick stock system. From here, the stock is pumped to the fan pump where it's diluted to final paper-making consistency. Here is something to remember. The amount of stock leaving the machine chest controls how heavy the paper will be when it's wound up on the reel, what papermakers call the basis weight. So very accurately controlling the flow of stock from the machine chest is critical. If you have variations in flow or consistency at this point, then you'll have variations in the basis weight of the final paper product. Some mills use a basis weight valve and open chamber called the stuff box control flow. Other mills use a very accurate variable speed pump to control the flow of thick stock. The stock at 3 to 4% consistency now enters the thin stock system, where it's diluted with white water from the paper machine. White water is water that's drained through the forming wire. It's very low consistency, but it still contains some of the fiber and fiber pieces that were deposited on the wire during the forming process. The fan pump takes the thick stock in the white water and combines them before several other functions of the thin stock system can be accomplished. Once we have the stock at low consistency, we have one final chance to remove any contaminants that might be in the furnish. What's a contaminant? Anything you don't want to be in the final sheet of paper, such as dirt, debris, small wood pieces, and plastics. The first way to remove contaminants is by centrifugal cleaning. By spinning the stock in a cone-like centrifugal cleaner, the heavy particles are forced to the outside of the cone, where they move their way out of the bottom of the cone and are discharged. Good fiber minus some dirt then exits the top of the cone. Each centrifugal cleaner can only handle a small flow, so there are usually large banks of them with backup or secondary and tertiary banks of cleaners to recover any good fiber that might have exited the bottom of the primary cleaners along with the dirt. Another way to remove contaminants is by screening. This piece of equipment is called a pressure screen because it's enclosed and under pressure from the pump that feeds it. Pressure screens can be used in the thick stock system as well as the thin stock system to remove contaminants that are larger or less flexible than cellulose fibers. Screen baskets have holes or slots that allow good fiber to pass through while trapping debris that we don't want in the paper. A rotating hydrofoil provides positive and negative pressure pulses in order to keep the holes in the screen from plugging. We skipped over one piece of equipment found in the thin stock system of many paper machines, and that's the de-aeration chamber. Small air bubbles can build up around fibers as they make their way through the stock prep system, and these air bubbles can cause small pinholes in the sheet and retard drainage during the forming process. The de-aeration chamber is under vacuum, so the stock is allowed to boil even at temperatures much lower than 100 degrees Celsius or 212 degrees Fahrenheit, and this boiling action releases the air in the stock. From the de-aeration chamber, the stock is fed to a second large pump and then to the pressure screen, which we discussed a minute ago. From the pressure screen, the stock enters the manifold for the head box and then is jetted out onto the forming section of the paper machine. Now let's look at the main piece of equipment in the paper mill, and that, of course, is the paper machine. Remember, however, that stock prep is an integral part of the paper machine. If anything goes wrong in stock prep, the paper machine quickly runs out of stock and must be shut down. Since we're discussing downtime, you need to know that paper machines don't have very much of it. That is, most paper machines run pretty much continuously, 24 hours a day, and perhaps 350 or more days per year. There are short maintenance shutdowns scheduled and perhaps an annual longer shutdown for major capital improvements. Why push the equipment so hard?